negative I. Okay. Alright. What's up?
Hi.
Hello. So we're doing some more complex numbers. We're starting reviewing the old stuff and then going into some new stuff. Hopefully you all studied up to know what this dinosaur is, because I forgot what it's called. Okay, so I'm going to bring my chart with me, because this chart is always good. Copy. So Caitlin already did the first couple. She's ahead of us. She's smart. We're going to try to catch up real quick though. So our first question was, what is I? Is it 34th?
I to the negative 17.
No, the one before that.
Yeah, I to the 34th.
Alright, so we had I to the 34th. So we break this down. We want some multiple of 4. So 8 times 4 is 32. So we can say I to the 32nd power is just equal to 1 times I to the second power. 32 and 2 makes 34. So we have 1 times I to the second, which is negative 1. And we get an answer of just negative 1. Alright, nice and easy. Then we had number 2, which was I to the negative 17th.
And so it's going to be I to the negative 20, because you want to keep the negative in the bigger sign, or else it won't work out.
Okay.
And then the other one is going to be the difference between 20 and 17, which is 3. So you can get it the same if you multiply it again. But in this case, you're going to take the negative 20 and it's going to become 1, because I to the 4th power equals 1. And then the I to the 3rd is going to become a negative I, because I to the 3rd always equals negative I. And then that's just going to be negative I.
Check. Hopefully you can hear over there. Alright, so that's 1 and 2. Not so bad. Alright. 3 and 4 were a couple of negative square roots. So we have the square root of negative 25, and we have the square root of the next one, which is over here hiding, negative 24. So these answers should be relatively close to each other. So the first thing we would do to you
with I want to get to the 4th power of this, sort of.
Negative.
We're taking 4s out? Or
no.
What are we doing? I forgot.
This is different. So you did the first step correctly. You want to get rid of the square root of a negative number. So we say, now let's go through the steps just in case somebody forgot. This is the square root of negative 1 times the square root of 25. Okay, the square root of negative 1 is I. And now we just need to figure out what is the square root of 25. This middle school math is just 5. So you have I times 5, which is
5i.
5i. And you're done.
Let me write that down on the side so you can see I did work.
She did work, people. You heard it here. Table version mismatch. Yeah, the tablet thing was like freaking out. You tried to move from left to right, it was like so we had to restart. It's not happy with me. Alright, so negative 24.
Equal to I to the...
So again, we get rid of the square root of negative 1. That's just I times the square root of 24.
I don't think 24 has a square root.
No, it does not. So we try to factor it out. So what times what equals 24? Preferably one of those factors is a perfect square. 4 times 6. Very good. So this is I times the square root of 4 times the square root of 6. And we can actually do the square root of 4. That's 2. Square root of 6, not so much. So we have I times 2 times 6, or the square root of 6.
2i to the square root of 6 in your answer.
Times square root of 6. That's it. Piece of cake. Oh man, you should have had some of that cake today. That was good cake.
I know, my dad always makes cake.
You guys should have had some cake too, but you're not in with the family like I am. So, feel free to be jealous. Alright,
Okay, the
we
next
ready?
one is the square root of -7.
Oh, that's kind of boring. Wait, that's really boring.
And that's just
If you have this,
I to 7.
7 is horribly prime, so you can't factor it at all. So this is just going to be I times the square root of 7.
Now we have this mess.
Ah, okay, so next one, a little different. Instead of doing the square root, now we're taking the cube root. Wait, I'm suddenly reminded. Okay, so what was cube root of -27? Alright, so depending on what level you're at, this answer might come out a little different. We're going to assume we're at a very basic level. So when you say the cube root, we're thinking what number times itself 3 times will give you -27? Which in the simplest terms would be -3 times -3 times -3. Because that equals 27. And negative times a negative is positive, and then a positive times a negative goes back to being negative. So the simplest answer to this is just to put -3. Okay? And you can argue against it not being imaginary simply because this works. Not to say that's the only possible answer, which is where you get into the higher level logarithmic ways of doing this. So another way you could look at it is like this. If you factor the -27 into its parts, so if we say it's the cubed root of -1 times the cube root of +27. Okay, because then you could take this is definitely equals 3. And then this is just the cubed root of -1.
And that'd be your answer.
This is technically correct. And then you can do some pretty advanced stuff with the cube root of -1. But you haven't gotten there yet, so you probably won't get there. So this is probably a pretty safe answer. This is also a pretty safe answer. Alright. Fair enough. Good enough explanation for tonight. Okay. Next one isn't so difficult. We have square root of -8 times the square root of 27. No. You cannot combine two negative radicals.
Oh, so we had to just take the I out and then multiply, right?
Right. Because if you combine them, you would end up with a positive number, and that would completely refute the fact that there's imaginaries in there. So we'll see what happens when we leave them in. So if we take -8, we can say that's I times what?
Times I.
No, we're just looking at -8. Factor 8.
It's gonna be 8.
Factor 8 though.
It's gonna be 2.
And 2 times what number is 8?
2 times 4.
Good. So we have I times square root of 4 times square root of. Whoa, that's bad. That's bad. Hold on. Go back. 4 times square root of 2. So that's on one side, right?
So I have to break it up into teeny tiny.
Yep. And then on the other
side. Why can't it just be the square root of 4? Why can't it just go to 2?
it does. Like the square root of 4 is definitely, if you want to work out this side first, square root of 4 is 2.
Yeah, then how come that one's there?
What, this one? Because 4 times 2 is 8. We had to factor out 8 first.
Okay.
So we have 2 times the square root of 2, and then there's an I here. How about the other side?
The other side's gonna be I
So 27 would look like.
The square root of 3.
And what else? 3 times what is 27?
Oh, wait, no, it can't be square root of 3.
Sure it can. 3 and what? 3 times what number is 27?
6.
9. Okay. So the square root of 9 times the square root of 3. And this is a good factor because what's the square root of 9? 3. So now we have 3i times. That's the square root of 3. I'm just going to write this down. Alright. So now we can combine our. Wait, can we combine our. Alright, so once we get here, now we just multiply. So this is. I'm going to rewrite this. This is 2i times square root of 2 times 3i the square root of 3. And we're just going to multiply these straight up. So 2i times 3i is.
2i times 3i is 6i.
6i what? What's I times I? Squared. And then we can multiply our square roots together. So square root of 2 times square root of 3 is square root of 6. No, can't do that.
No, which is 6. Which is 3, which comes out.
You can't mess with. You can't do square root of 6.
Oh, yeah. I was thinking of 9.
Yeah, that's okay. But can we do something with I squared?
Yes, we can make it into a -1.
Very good.
Times -1.
So then.
-6 to the square root of 6.
There you go.
And this one's going to do it like distributing like that.
Sort of. So before we go, the reason why you can't just combine these straight off is you would get this, but you would have lost the negative sign because of this I squared. So instead of 6 times square root of 6, you would have had 6i times square root of 6, and you'd be off by a lot. Yeah, you would be cat knows. Alright, so what's next?
It's 5 times -6 to the square root.
That's a mess. So 5 times square root of 6, or -6, you covered it up, times, you're still covering it up. Why are you so right-handed? -7 times square root of 2. -2. So this is sort of like the last one. Before we can really mess with it, you have to take out the i's. Oh, which you already did. So now we have -5i times square root of 6. Okay. Times -7i times square root of 2. Okay. So we multiply our constants together. So -5 times 7 is.
-5 times -7.
Yeah, you don't know your times tables. That's kind of bad. It's 35.
35.
Okay.
Positive.
Positive. And then we have I times I.
Which is I squared.
Right? Then we multiply our radicals together. So square root of 6 times square root of 2.
12.
So square root of 12. Ah, you know your 2's times table. Hey. Alright. So let's get rid of the square root first. Can you break that down?
Yes, sir.
To what and what?
35 times.
No, just the radical. Square root of 12. Factor 12.
6 times 2.
That's not going to work so well. We want one of the factors to be a perfect square.
4 times 4.
Getting close. Why don't you know your times tables?
4 times 4 is
12.
Oh,
It's not 12. It's not 12. It's 16. What is this? 4 times. 4 times. Come
4
on.
times 3.
There you go. Okay. Square root of 4 times square root of 3. You got me messed up now. Thank you. So now we can do this. The square root of 4 is
2.
Yay!
2 times 35.
So we have 35i squared times 2. So 2 times 35 is 70.
70.
Can we work out I squared? What's that?
Negative 1.
Negative 1.
Which would be
And then,
negative 70.
so we get negative 70 times the square root of 3. Alright, we doing okay? Oh, okay, on the back. We're only on the back, man. And those were the easy ones on the front. It took us 16 minutes. Of course you do. It's 10 o'clock. It's time to start your homework, huh? So, square root of negative 18 all over 6 times square root of 5. So what did they tell you about radicals in the denominator?
It can't be negative,
Really?
I think.
So they said radicals in the denominator are totally okay as long as they're positive?
There can't be any.
Yeah, you don't want them.
You can't have them.
You don't want them. So how do you get rid of them?
You times them by the same thing.
Okay.
Right?
Yes. So why, oh why, does it make sense to multiply the top and the bottom both by the square root of 5?
So it makes it even.
Well, that's part of it. It's got to be the same number, numerator or denominator, because this equals 1, and you can multiply stuff by 1. But why just that? What is the point of square root of negative 5? What is the reason why we choose this number?
You have a square root, and you can make it a square root, and then it becomes a number instead of.
So you're saying that if you take the square root of 5 times square root of 5, you get the square root of 25, which is just 5. And so now you have 6 times 5, which is 30. So in reality, we've rewritten this denominator as being 30.
Yes, sir.
And now it's radicalless. Radicalless?
Sure.
Free of radicals, which is what we want.
Yes, sir.
So now we just need to deal with this top part. So we need to know what is square root of negative 18 times square root of 5. Okay. Okay. Can we combine those?
Yes.
Yes. Why can we combine those?
Because we have.
That's not a very good reason.
Because I need to multiply to go to the bottom.
We can combine them because only one of them is negative.
Okay.
Remember, you can't combine them if they're both negative.
Yes, sir.
Because then you get I squared and it changes the answer. But since one's positive, one's negative, it's going to continue to be negative. That's cool. So 18 times 5. Yeah, she'll be at this all night, people. That's 80. Wait, is it 80? I don't know. It's 18 times 5. 36, 72. No, it's 90. Who taught me math? 90. Wait, is it 90? Yeah, it's 90. So we need to work out what's the square root of negative 90.
30.
No. 30? For real? Okay, first we need an I, right? That gets rid of our negative. What times what is 90? Dude, my square root signs get worse and
9
worse.
times 10.
9 times 10. Very good. Why do we use 9 times 10 instead of 30 times 3? Because the square root of 9 is trace. So we get 3i times square root of 10. Yeah?
Yep.
Yep. So that's our new numerator. 3i square root of 10. This is correct, but not the most correct. How could we make this better? Divide by what? 3. So we divide both these numbers by 3. We get, because we always simplify in math, 30 divided by 3 is just 10.
But when you're dividing, you don't mess with the radical.
No, because you can't divide a radical by a constant. Because they're different.
Can we somehow take the bottom and put it on the top?
No. Not really. Fair enough?
No. Negative 14 I squared.
So it's saying we could also put I times or over the square root of negative or positive 10. I don't like this way. Most of your math teachers don't like this way because radicals in the denominator is sort of a pain in the butt. So I'd take this answer. Alright, so now we're doing FOIL with complex numbers.